In section 9, we're going to take a look at volume and surface area of composite solids. So what that means is that you've got two or more different solids making up your shape. So for volume, what you want to do is split up your figure into the two known solids and find the volume of each solid and then add them together. Surface area is where it gets a little bit trickier. So let's start with our first composite solid here. We want to find the surface area and the volume. So I want to find the volume first, and I want to split it into two rectangular prisms. And you have two choices. You can split going down here, or you can split going across the top. It doesn't matter which. I'm going to go with across the top. So I'm going to split it into my two rectangular prisms here. Before I start finding any volume of surface area though, I'm going to go ahead and label the lengths that I don't know. So if I have a 60 millimeters here, I have 60 millimeters here, 40 millimeters here. This side is 10 millimeters, which means this is 10 millimeters, which means this side is 10 millimeters. Okay. If the entire bottom is 80 millimeters and I have 60, that means this is 40 millimeters, which means this side is also 40 millimeters. And then if I'm breaking up, then it's also 40 millimeters just from where I've broken it up to the top. So now I have to pick one of my rectangles to be the base, and I'm going to choose that rectangle. So the volume of my first rectangular prism, I do the area of the base, which is a 40 by 10, and then I multiply it by the height, and its height is 40. So 40 times 10 times 40, it's going to give me a volume of 16,000 millimeters cubed. Okay. Now I want to find the volume of my second prism. So I'm going to choose my base to be this rectangle. So this has to be 20 millimeters to add up to the 60, which means this side here is also 20 millimeters. So my rectangle has an area of 20 times 10 times the height, which is 80. So 20 times 10 times 80 is also 16,000 millimeters cubed, which means the volume of the entire prism is 16,000 plus 16,000, which is 32,000 millimeters cubed. Okay. So like I said, volume is the easier one because all you have to do is find the volume of each solid and add them together. Surface area is where it gets tricky because you have your composite solids put together, there's going to be a shared side. And you want to account for that by not including it in the surface area. So typically, for surface area, we would just use our formula where you do 2 times the area of the base plus the perimeter of the base times the height. But in this case, we have to account for the piece that is shared. So we typically just break it down and find the area of all of our faces and just add them all together. So what I'm going to do for my surface area is, surface area is the area of the outside. So if I start with that first prism, and I want to find the area on the outside, I find the area of all of the rectangles. So I have the area of my top rectangle, which is a 40 by 10. Okay. Then there's my front-facing rectangle, which is actually a square. It's a 40 by 40, and there are 2 of those, because there's one in the front and then there's one on the back side. And then there's my 2 rectangles on the sides that are 40 by 10s. So this is the surface area that makes up my first prism. So 40 times 10 is 400. 40 times 40 is 1600, and then we have to multiply that by 2 because we have 2 of those. And then we have 2 of them that have an area of 400. So the surface area that's going to come from my first prism is 4,400 millimeters squared. Now we want to find the surface area of our second prism. So we have that, we have our base, 2 bases, the 20 times 10. So we have 2 that are 20 times 10. We have the front facing piece, which is an 80 by 20, and we have one of those that's also in the back, so 2 80 by 20s. We have the entire bottom rectangle that's an 80 by 10. And then we have that top rectangle that is a 60 by 10. So 20 times 10 is 200, and we multiply it by 2, plus 80 times 2 is 1600, which we also multiply by 2, plus our area of 800, and then our area of 600. And we end up with 5,000 millimeters squared. So if we had just found the surface area of each rectangular prism and added together, what happens is we end up with extra surface area, because inside there's this little piece that's the base of my first rectangular prism, and that's part of the base of my other rectangular prism that's actually inside my composite solid. And I can't count what's inside as part of the surface area, which is why we can't just find the 2 surface areas and add them together, because there would be extra surface area included. So my total surface area takes my 4,400 and adds the 5,000, and we get a total of 9,400 millimeters squared. All right, so our next composite solid, if we look at it and we break it up, the top is got a cylinder in it, and the bottom is a rectangular prism. Okay. So first we want to find the volume of the cylinder. Now we aren't dealing with an entire cylinder, we're dealing with half a cylinder. So I'm going to use half of the volume of a cylinder, which is pi r squared h. So now I want to plug in what I know. So 1/2 times pi. Now if I look, I actually have a square rectangular prism, because this base shape is a square, which means that the diameter of the cylinder, the circle base, is 6, which means the radius is 3. The height of the cylinder, if we look at our rectangle, that is also 10 meters, so its height is 10. So we're doing 1/2 times pi times 3 squared, which is 9, times 10. And we're going to get 141.37 meters cubed. Now we want to find the volume of our prism, which is the area of the base shape, which I'm going to use to be my square that is a 6 by 6, so 6 times 6, times our height, which is 10. So 6 times 6 is 36, and 36 times 10 is 360 meters cubed. So that means the volume of my entire solid is 141.37 plus the 360, which is 501.37 meters cubed. Now we want to to work on the surface area. And I'm going to start with the surface area of the cylinder. Okay, so this is where the surface area of the cylinder gets a little bit tricky. So typically we do 2 pi r squared for the surface area of both of our circular bases, and then 2 pi r h, which represents that rectangular in the middle. But I am only dealing with half a circle on both of my bases. So I really only need the area of one circle, and I'm only dealing with half of my rectangular in the middle, so I really just need pi r h because half of 2 is 1. So we're going to do 3 squared times 10 for the pi r squared. We're going to do pi times 3 squared, and then plus pi times our radius 3 times our height 10 for the surface area in the middle. So pi times, and then 3 squared is 9, plus pi times, and then 3 times 10 is 30, which gives us 122.52 meters squared for our cylinder. Now I want to find the surface area of our prism. So we have our square base, and we're going to have 2 of those. So 2 of our 6 by 6s. Then we have our rectangular sides, and there's one that we can see, and then there's one on the other side that we can't see. So there are 2 of those that are 10 by 6s. Then we have the bottom of our solid, which is another rectangle that's a 10 by 6. So 6 times 6 is 36 times 2, plus 10 times 6 is 60 times 2, which is 120, and then plus 60, giving us a surface area of 252 meters squared for our prism. So it means our total surface area is the 122.52 plus the 252, giving us a total surface area of 374.52 meters squared. All right, next we have a cone and what looks to be a sphere. So first we're going to start with our volume. So first I'm going to start with the volume of the cone. Okay. So looking at our formula sheet, the volume of a cone is 1/3 pi r squared h. So we have our radius labeled 8, and our height is labeled as 20. So we're going to do 1/3 times pi, and then 8 squared is 64, times our height, 20, and the volume of our cone is 1,340.41 inches cubed. Next, we have the volume of our sphere, and it doesn't look to be an entire sphere, it looks to be half a sphere, so a hemisphere. So from our notes, the volume of a sphere is 4/3 pi r cubed, but then I want to only half that. So it's 1/2 times 4/3 pi r cubed. So 1/2 times 4/3 pi, and then again our radius of 8 cubed. So I'm going to do 1/2 times 4/3 times pi, and then 8 cubed. And we get 1,072.33 inches cubed. So our total volume is going to be the 1340.41 plus the 1072.33. So 1340.41 plus 1072.33. And we're going to get a total volume of 2,412.74 inches cubed. So now I want to work on the surface area. I'm going to start with the surface area of the cone. From our formula sheet, we know that the surface area of a cone is pi r squared plus pi r L. Now, L represents the slant height. So L is the height of the outside piece of the cone. So I need to solve for that first using the Pythagorean theorem. So we're going to have 8 squared plus 20 squared, because our radius and our perpendicular height make up the sides of our right triangle, equals L squared. 8 squared is 64. 20 squared is 400. So we have 464 equals L squared. Then we take the square root, and we get that we have a slant height of 21.54. So when we find the surface area of our cone, we don't want to include the circular base because it's inside our figure, and surface area can only account for area outside. So we're only going to use the part of the formula that's pi r L. So pi times our radius 8 times our slant height 21.54. So pi times 8 times 21.54. And we get 541.36 inches squared. Now we want to work for the surface area of our sphere. So the normal formula for the surface area of a sphere is 4 pi r squared, but that accounts for an entire sphere. But we only want half the sphere, so the hemisphere, and we don't want to include the circular base, so we actually use the formula 2 pi r squared. So we're going to do 2 pi times our radius 8 squared. So 2 times pi, and then 8 squared is 64. And we get 402.12. So that means that our total surface area, we're going to do 541.36 plus 402.12, and we get 943.18 inches squared. So our last figure is a cylinder on top of a prism. So we have a cylinder and a rectangular prism. So I'm going to start with the volume of the cylinder. So volume of a cylinder is pi r squared h. So we know the radius of our circular base is 2. And we know the height of the entire cylinder is 4. So pi times 2 squared is 4, times our height 4, and we get 50.27 centimeters cubed. Next, I want to find the volume of the prism. So I'm going to choose my base to be the square here. So the volume is the area of the base, so 5 times 5, and then times our height, 8. So 5 times 5 is 25, times 8 is it's going to give us 200 centimeters cubed. So that means our entire volume is 50.27 plus 200, which is 250.27 centimeters cubed. So our surface area, it's actually going to get a little bit tricky when we do the surface area of the prism. So I'm going to start with the surface area of our cylinder. So we want to find the surface area of our cylinder, but we don't want to include one of our circular bases since it's technically inside our figure. So the surface area of our cylinder, the formula is 2 pi RH plus 2 pi R squared. So we're going to include the 2 pi RH, but instead of including both of our circular bases, we're just going to do pi r squared because we only want one of them. So we're going to have 2 pi times our radius 2 times our height 4 plus pi times 2 squared. So 2 times pi and then 2 times 4 is 8 plus pi times 2 squared is 4. We're going to get 62.83 centimeters squared. So where it gets tricky is actually with the surface area of our prism, because our cylinder doesn't fit the entire side of one of our prism sides. So I actually have like a part of an area on the top that I want to include. So I'm going to start with the area of my two bases, which are my two squares, which have an area of 5 times 5. Then I'm going to start with my two rectangles that one is directly facing us and one is directly in the back. So there are two of those with an area of 8 times 5. Then there's that bottom base, which also has an area of 8 times 5. So here's where we get the tricky part, is that top rectangle. We want the area of the rectangle, which is 8 times 5, and then we want to subtract the area of the circle, which is pi times the radius 2 squared. So that's where the tricky part comes in, is because we want to take out a part that's covered by the circle. So I'm going to find the area of my whole numbers first. So 5 times 5 is 25, times 2 is 50, 8 times 5 is 40, times 2 is 80, and then 8 times 5, which is 40. So that's 170. Then I have to do 4 times pi, which is 12.57, and when I subtract it from the 8 times 5, which is 40. So it's 40 minus the 12.57, which is going to give us 27.43. So that's the area of the top rectangle that's not taken up by the cylinder. So when we add those together, so 170 plus 27.43, we're going to get 97.43 centimeters squared. So that means our total surface area is the 62.83 plus the 97.43 and we get 160.26 centimeters squared. I know this is not an easy concept, especially the surface area portion of it. So please, please, please ask for help on the assignment in class. I'm more than happy to work through the problems with you to make sure that you're grasping the concept.